Alright, so we're talking about simplifying expressions, and what you're going to need for this section is you're going to need your formula sheet in front of you. Let's get started with this example. I have secant theta times cosine theta. So what I'm going to do is I'm going to look at my formula sheet and I'm going to realize that secant theta could really be written as 1 over the cosine. So I have 1 over the cosine of theta times cosine, which I could write as cosine theta over 1. So when I multiply those out, just like a normal old fraction, I'll wind up with cosine theta divided by cosine theta, which is a 1. And that's it. We've just simplified my expression secant times cosine, and that's just a 1. Let's try this one. I've got sine theta times cosecant plus secant. So I've really got sine theta times, now cosecant, looking at my formula sheet, I know cosecant is 1 over the sine of theta, plus secant, and I know that secant is 1 over cosine. And if I multiply through, so I'm going to multiply the sine times each one of these guys, sine times 1 over sine and sine times 1 over cosine, I'm going to get sine theta over sine theta plus sine theta over cosine theta. Well, sine over sine, that's just a 1. And let's see, let's pick a different color. Sine over cosine, well, look at my formula sheet, and sine over cosine is just tangent. So I get 1 plus tan theta. And there we go. I just simplified down sine theta times cosecant plus secant into 1 plus the tangent. One more of those simplifying. Here I've got sine squared x times 1 plus cotangent squared x. Okay, well, let's see. I'm going to write that out as sine squared x times 1 plus the cotangent. And cotangent, looking at my formula sheet, cotangent is really cosine over sine. So it'll be cosine squared x over sine squared x. Now when I multiply the sine through, I'll get sine squared x times 1, which is just sine squared x, plus sine squared x times, we can think of that as cosine squared x over 1, over sine squared x. But think of the sine squared x as sine squared over 1. So let me pick a different color. So the sines will cancel. And so I'll be left with sine squared x plus cosine squared x. And from looking at my formula sheet again, that's a Pythagorean identity, and so that's just a 1. So this whole thing simplifies down to 1 because that's a Pythagorean identity. Okay. Get one more example for us. Not so much a simplifying as just a slightly different problem. We're supposed to find cosine theta if sine theta is equal to x. And I didn't write that in, so and theta is acute. So no, theta is in the first quadrant. So the first thing I'm going to do is I'm going to draw myself out an XY coordinate plane. Here we go. And let's put an angle somewhere in the first quadrant. So I'm going to put an angle right here. And I'm going to call this angle angle theta. Now I know sine is supposed to be the opposite over the hypotenuse, and since sine of theta is an x, I'm going to say that's going to be x over 1. Right, that's the opposite over the hypotenuse. The next thing we have to do is figure out what this side is. Well, I know from the Pythagorean identity, or from the Pythagorean theorem, that a squared plus b squared equals c squared. So let's call this a and b. So I'll have a squared plus x squared equals 1 squared. So a squared equals 1 squared, which is 1, minus x squared, or a is equal to the square root of 1 minus x squared. Right, so that's what goes right here. That's that missing side, is the square root of 1 minus x squared. So now I can easily find cosine. So the cosine of theta is, well, it's the adjacent over the hypotenuse. So it's the square root of 1 minus x squared, the whole thing over 1, or just 1 minus the square root of 1 minus x squared. So there we go. We've just found the cosine of theta, given that the sine of theta was just an x.